We now determine whether the function given as x cubed minus 8, if it is one-to-one or not, and then answer the following questions in part A, part B, and part C. So first, let's determine whether the function is one-to-one. Let me copy the function. We have f of x equal to x cubed minus 8. Remember that a function is one-to-one if no two inputs of x gives different values of y. For example, if you consider a function like this, here you can say that for this value of x1 and for this value of x2, it gives the same output. Let's say this output is a, then both values of x1 and x2 gives the same output a, which means this is not a one-to-one. So in other words, we can say that it should pass the horizontal line test. So if I draw a virtual horizontal line like this, it does not pass the horizontal line test because it is every time it makes two intersection with the graph of the f of x. So which means this is not a one-to-one function. A good example of a one-to-one function is a cubic function. A cubic function looks like this. So you can imagine that if you pass a it's a horizontal line test. So every time you pass this horizontal line test from top to bottom, it does not make more than one intersection. So it makes just one intersection with the graph of the f of x. So this is graph of x cube, which is this is 1-to-1. However, this is the graph of x squared, which is a parabolic curve, and this is not 1-to-1. So this gives us a basic idea of how to determine whether the function is one-to-one or not. Now considering the function given in this question, let's write it down. We have f of x equal to x cubed minus 8. So we can also determine if it is one-to-one using algebraic method. So in algebraic method, what we do is we first take an input and find the value of the function. That is, let's say if we take the input a, then f of a is equal to x cube. It is a cube minus 8. And we take another output b and we find the value of this function at b, that is f of b, which is equal to b cube minus 8. And suppose if we let f of a equal to f of b, then we should get the result as a equal to b, which means uh, the value of the function is unique. In that case, the value of x is also unique. So this says that the function is one-to-one. So let's check that. We now need to let f of a equal to f of b. So when we do that, we get a cube minus 8 equal to b cube minus 8. Now we can cancel this negative 8 on both sides. So I'm going to subtract the b cube from both sides. So I get a cube minus b cube equal to 0. Which means if I simplify this using the algebraic identity, I'll be getting a minus b times of a squared plus ab plus b squared equal to 0. And this implies either this term is 0 or this term is 0. This term, when you put it to 0, it does not have solutions, or it gives solutions as a imaginary number. It's not a real solution. So we can just ignore this and we take only this equation. So we let a minus b equal to 0. This implies a equal to b. So we get the result as a equal to b if we let f of a equal to f of b, which means this function is one-to-one. Let's continue with the remaining part of this question. So we have answered the first question, which is we have determined the function is one-to-one or not. In fact, it is one-to-one. Now let's move on to the next question, that is a part A. We have to determine the equation for an inverse of the function. So let's do that. Let me copy the function. we have f of x equal to x cube minus 8. So to find the inverse of a function, we follow the method. That is, first we replace f of x by y. So therefore this becomes y equals x cube minus 8. And in the next step, we interchange x and y's. So therefore this becomes x equal to y cube minus 8. And then we solve for y from the equation after we replace the, or we interchange the x and y. So now I'm going to add 8 on both sides. When I do that, I get x plus 8 equal to y cube. So this implies I need to solve for y from this equation. I take cube root on both sides, so then I get y equal to cube root of x plus 8. So this is basically the inverse of the function. And in the final step of the finding the inverse for any given function, we replace y by f inverse of x. So therefore the f inverse of x equal to cube root of x plus 8. So this is the inverse of the function f of x equal to x cube minus 8. So we have answered the question in part A. We determine the inverse for the given function. Now let's move on to the next question, which is we have to graph the both function, that is function f and function f inverse. So let's do that. So we first copy the f and f inverse. F is x cube minus 8 and f inverse equal to cube root of x plus 8. So to graph these functions, either we can do by the general method of tabulating some random values and then plotting the points on the graph. Otherwise, what we can do is let's first graph the function f. We can find the intercept and see how the function is behaving as x increases in both sides. So let's first find the intercept for the function f, the x-intercept and y-intercept. The x-intercept we have to put y equal to 0, which means if I put y equal to 0 here, that is f equal to 0, I get the relation x cube equal to 8. So this implies x equal to 2, which means the x-intercept of function f is 2 comma 0. And similarly, to find y-intercept, we have to put x equal to 0. So when we do that, we get negative 8 comma 0. So we now know these 2 points, vital points. We can graph it on the x and y axis. So we put x here, we put y here. We are graphing the function f. So the x-intercept is 2 comma 0 for this function, which means this is basically 2 comma 0. We mark a point over here. This is 2 comma 0, or we can just note it down as 2. And then the y-intercept is negative 8 comma 0. Let's say this is negative 8. So we can connect like this. This is how it goes. Now let's put some values greater than 2. If we plug in, let's say we plug in 4, this is going to be 4 cube minus 8, which is greater than 0. So it's going to be positive beyond 2. So we can say that it goes like this. It just increases like this, because at 4 it will be like 64 minus 8, which is approximately 52. So at 4 it is 52. And now let's put some value between 2 and 0. Let's say if we put x equal to 1. If we let x equal to 1, this will be 1 cube minus 8, which is a negative number. So that is why I have drawn it by connecting these two points like this. So it is negative till this point minus 8. And now let's put some negative values of x. So if we put x equal to negative 1, this becomes minus 1 cube minus 8. So when we do that, we get minus 1 minus 8, which is again a negative value. So which means that negative 1, it is negative. So this is how the function behaves. Also, when you put some larger negative values like negative 4 or negative 6 or something like that, is again going to be some negative values only. So which means we can plot it like this. So let me just clean it up and draw a nice graph. So after that, we'll be getting the graph as like this. I'm sorry, this line is going awkward. Okay, so it is something like this. This point is 2 and this point is -8. This is x and this is y. So we have drawn the graph of f. This is the graph of f. In the same way which we have done it for graphing f, we can also do some analysis for f inverse. We have to consider the equation f inverse equal to cube root of x plus 8. Find the x and y intercepts and then let x greater than the x-intercept as well as x less than the x-intercept, and then determine how the function is behaving. So when you do that, we'll be getting a graph like this. This will be the graph of f inverse. Okay, so we will have x-intercept over here. In fact, x-intercept will be we have to put y equal to 0. When we do that, we get x plus 8. This is power of 1 by 3 equal to 0. So when you cube on both sides, we get x equal to -8. So basically this point is -8 comma 0 and this point is 0 comma 2. Okay, so this is the graph of the f inverse. We have drawn it both on the same graph. Now I have done it graphing this on a graphing software. So let me bring it over here. So this is how the graph of f and f inverse looks like, which we have drawn it over here. So this is the graph of f and this is the graph of f inverse. You can clearly see that this is a y-intercept -8 and this is x-intercept 2 for the graph of f, and this point is -8 for the x-intercept of f inverse, and this point is 0 comma 2, which is the y-intercept is 2 over here. So this is how the graph of f and f inverse looks like when we draw it on the graph. So we have answered the question, that is we graphed it, and then finally we have to determine the domain and range of the f and f inverse, so which can be done using the graphs of both f and f inverse. So let's figure out the domain of f. As you can see that it takes all the values of x on a real number system, which means for f the domain is all real numbers. So we can represent this in interval notation as -infinity to +infinity. Similarly, the range is, it has all y values starting from -infinity to +infinity. So here the domain and the range is also both are the same, -infinity to +infinity. And similarly, if you look at the graph of f inverse, the domain is once again all real numbers. So therefore the domain is in interval notation. We can represent this as -infinity to +infinity. And similarly, the range is also all y values goes from -infinity to +infinity. So this is also -infinity to +infinity. So here we have answered all the three questions of this question.